CIET NCERT presents audiobook Curiosity, Textbook of Science for Grade 7.
Page number 23, Chapter number 3, Electricity, Circuits and their Components. A QR code is given at the right side of the page, on scanning to which you can get access to other resources of the chapter. Nihal and his classmates were excited for their school trip to the Bhakra Nangal Dam. There, they would visit the hydroelectric powerhouse where the force of falling water was used to generate electricity. They also looked forward to the free 13-kilometer train ride from the Nangal in Punjab to Bhakra in Himachal Pradesh, along the beautiful Satluj River and through the Shivalik Hills. Prior to the trip, Nihal and his classmates were given a group assignment to prepare a presentation on the uses of electricity. They began by looking around their houses, then their school, followed by their neighborhood, their city, and finally they searched the internet. To their astonishment, their list kept growing. They decided to organize the uses under different headings. Let's list out some uses of electricity under some categories. First category is cooking. So there are some uses of electricity: electric kettle, mixer grinder, toaster, oven, microwave. Blank space is given for you to state some more examples. Second category is lighting. Homes, offices, streets, markets, factories. Next category is transportation. Train, bus, car, scooter, lift, escalator. Next category is heating and cooling. Fan, room heater, immersion rod, geyser, refrigerator, air conditioner. Next category is entertainment. Television, radio. Next one is communication. Mobile phone, internet. Some others are water pump, crane, computer. You can add some more examples to these categories. At the bottom of the page, a picture of Bhakra Nangal Dam is provided. Page number 24. Can you help Nihal by adding some more uses to his list? Also, suggest some other ways of grouping the uses of electricity. We use electricity all the time, so let us learn something more about electricity. You have learnt earlier that the electricity is generated in multiple ways: by windmills, by using wind energy, by solar panels, capturing the sun's energy, by falling water, and by using natural gas or coal. In the chapter Nature's Treasures in the Grade 6 Science textbook Curiosity, the electric supply from these sources reaches our homes and factories via wires. For example, at home we plug in various devices to the electrical sockets in the wall. However, to learn about electricity, we will focus on a portable source of electricity that most of us may have used. Let us start with its use in a common device like a torchlight. The electric supply from these sources reaches our homes and factories via wires. Please note the caution message provided here. The danger signs on electric poles and other appliances warn people that electricity can be dangerous if not carefully handled. Never ever perform experiments with power supply at your home or school. Even electricity from portable generators can be dangerous. Use only batteries or cells like those in torchlights, wall clocks, radios, or remotes for experiments with electricity. At the middle of the page, in the right side, a sign of high voltage electricity is given. 3.1 A torchlight. You might have used a torchlight, also called a torch or a flashlight. Activity 3.1 Let us explore. In the left side of the page, a picture of torchlight is also provided, which is a basic flashlight with a lamp and a sliding switch. Let us explore with activity 3.1. Take a torchlight similar to the one given in figure 3.1, which is a torchlight. Observe it carefully. Do you notice a lamp and a switch? Slide its switch and observe. Does the torch lamp glow? Now slide the switch back to its original position and observe the torch lamp. You might have noticed that in the first position of the switch, the torch lamp glows, and in the other position of the lamp does not glow. Now open the torchlight. What do you find inside? Inside the torchlight, you may find 2 or more electric cells. At the bottom of the page, a picture of a boy, Nihal, is given, who is saying, "Why does the torch lamp glow in one position of its switch?" Page number 25. 3.2 A simple electrical circuit. To understand how a torch works, let us first find out about its components. 3.2.1 Electric cell. At the right side of the page, you will find a figure 3.2, an electrical cell, which is cylindrical in shape, having positive and negative terminal marked on it. Now, activity 3.2, let us observe. Take an electric cell, turn it around and look at it carefully. Figure 3.2. Do you notice a positive sign and a negative sign marked on the electric cell? Do you also notice that it has a small protruding metal cap on one side and a flat metal disc on the other side? All electric cells have two terminals. One is called positive, while the other is negative. The metal cap is the positive terminal of the electric cell, and the metal disc is the negative terminal. The electric cell is a portable source of electrical energy. In the middle of the page, there is a picture of a girl is given who is asking, in a torch, we generally use more than one cell. Are those placed in any particular order? 3.2.2 Battery. Activity 3.3 Let us experiment. Take a torch which uses two cells. Open its cell compartment and take out the cells. Put the cells back in a different order. Also, try reversing the direction of one cell. Then slide the switch and check whether the lamp glows in each case. Check the order in which the cells were placed in the torch when the lamp glows. The lamp glows when the cells are placed in the order as given in figure 3.3. Notice how the terminals of the two cells are connected. The positive terminal of one cell is connected to the negative terminal of the next cell. Such a combination of two or more cells is called a battery. A picture is provided at the bottom of the page, figure 3.3. A battery made up of two cells. B. A battery made up of four cells. Page number 26. For many devices, we may need more than one cell. So, we connect two or more cells together as given in figure 3.3. Connecting more than one cell provides energy to the circuit for a longer time and or more energy. Fascinating facts. The term battery is also used for a single cell. We use the term battery even for the single cell that powers our mobile phones. 3.2.3 Electric lamp. Incandescent lamp. Activity 3.4. Let us observe. At the left side of the page, a figure 3.4a, a small incandescent lamp used in a torch is provided, where we can find a glass bulb with a thin wire glowing filament inside it, which is connected to two thick wires. The glass bulb is connected with a metal case, which will be considered as one of the terminal, and further it is attached to a metal tip, which will be considered as the other terminal of the bulb. It also have a insulator support connected to the glass bulb. Figure 3.4b, it's simplified drawing showing the connection of wires to the terminals. Activity 3.4, let us observe. For this activity, you will require a torchlight with an incandescent lamp or light bulb. Many old torchlights still use such lamps. With your teacher's help, confirm that your torchlight uses an incandescent lamp. Take the torch and examine its lamp. What do you find? Do you notice a thin wire fixed in the middle of the glass bulb? Now switch on the torch. Which part of the lamp glows? The thin wire inside the glass bulb of the lamp glows. The glowing thin wire is called the filament of the lamp. Take out the lamp with the help of your teacher and inspect it from all sides. How is the filament fixed? The filament is attached to two thicker wires that support it, as given in figure 3.4a. One thick wire connects to the metal case at the lamp's base, while the other connects to the metal tip at the center of the base. Figure 3.4b. These form the two terminals of the lamp and are fixed in a way that they do not touch each other. In such incandescent lamps, the filament gets hot and glows to produce light. At the bottom of the page, a picture of a boy is provided who is saying, "However, my torch has a different kind of lamp. In fact, it can't be taken out of the torch as it is fixed in it." Page number 27. LED lamp. Many torches in use today have a light emitting diode LED lamp instead of an incandescent lamp, as given in figure 3.5. Figure 3.5, an LED lamp for torch. Activity 3.5, let us observe. Take an LED of any color, figure 3.6, and observe. Do you find any filament inside it? At the right hand side and middle of the page, you can find figure 3.6, LEDs of different colors. You can also find their positive and negative terminals. Now, activity 3.5, let us observe. Take an LED of any color which is provided in figure 3.6 and observe. Do you find any filament inside it? Notice the length of the two wires attached to the LED. Do you find one of those longer than the other? Unlike incandescent lamps, LEDs do not have filaments, which you can find in figure 3.6. They also have two terminals, but one is positive, attached to a longer wire, and the other is negative, the shorter wire. A torch may use one or more LEDs, sometimes of different shapes, in its lamp. After having learnt about the electric cell, battery, and electric lamps, we are now ready to make the torch lamp glow using an electric cell or battery. 3.2.4 Making an electric lamp glow using an electric cell or battery. Activity 3.6 Let us construct. Point 1. Take an electric cell, an incandescent lamp used in a torch, a cell holder, a lamp holder, and 4 lengths of electric wire. Point 2. Remove about 1 centimeter of the plastic covering from both ends of each wire to expose the metal. Point 3. Attach 2 wires to the 2 ends of the cell holder as given in figure 3.7a. Page number 28. Figure 3.7a. An electric cell holder with 2 wires attached. B. An electric cell inside the cell holder. C. Wires connected to an electric cell using electrical tape. Point number 4. Insert the cell in the holder such that its negative terminal is towards the spring side of the holder, which is given in figure 3.7b. In case a cell holder is not available, fix the 2 wires to the cell using electrical tape, which is provided in figure 3.7c. Point number 5. Attach 2 wires to the screws of the lamp holder as given in figure 3.8a. Fix the lamp in the holder by turning it around in the holder, which is given in figure 3.8b. In case a lamp holder is not available, use electrical tape to attach 2 wires to the ends of the lamp, which is given in figure 3.8c. Now, 3 pictures are given in figure 3.8a. An electric lamp holder with wires attached. B. An incandescent lamp inside the lamp holder. C. Wires connected to incandescent torch lamp with the electrical tape. Now we are ready to connect the cell to the lamp to make it glow. We will conduct this activity in 2 parts: prediction and observation. Some of the ways in which the lamp and the cell can be connected are given in table 3.1. Predict for each arrangement if the lamp will glow or not, and write your prediction in table 3.1. Now connect the lamp and the cell and observe if the lamp glows or not. Note down your observation in table 3.1. Also, for the lamps which glow, color their glass bulbs yellow. Page number 29. A table where students predict and observe whether a lamp glows under various connections is provided here. Table 3.1. Trying to make the lamp glow. Note, the lamps are not given glowing in any circuit. In this page, there is a table which includes 4 columns and 6 rows, named as serial number, arrangement of cell and lamp, prediction, and observation. In the first row, you can find a circuit where both wires are correctly connected to opposite terminals of cell and lamp. There is a blank space provided in the prediction column. Also, you have a blank space to write your observations in the observation column. In the second row, you can find a circuit where one wire is not connected to the lamp. You can write your prediction and observation for this too. Third, one wire is not connected to the cell in the given circuit. Write your observations and prediction. Fourth, in this circuit, both terminals are connected to the same wire. Fifth, both wires are connected to the same terminal of the cell. Sixth, wires are connected correctly to the opposite terminals. You can write your prediction and observation in the blank space provided with each row. Page number 30. The lamp glows in the arrangements at serial number 1 and 6 and does not glow in the remaining arrangements. Now, observe carefully at the arrangements in which the lamp glows in previous table. Compare these with those in which the lamp does not glow. Can you find the reason for the difference? 3.2.5 An electrical circuit. At the left side of the page, there is figure 3.9, an electrical circuit. You can find a closed loop circuit where lamp glows due to proper connections. The lamp glows when one terminal of the lamp is connected to one terminal of the electric cell and the other terminal of the lamp to the other terminal of the cell, as given in figure 3.9. This setup forms an electrical circuit, which provides a complete path for electric current to flow through the lamp. The lamp glows only when current passes through the circuit. The direction of electric current in an electric circuit is taken to be from the positive to the negative terminal of the electric cell. When the terminals of the lamp are connected with those of the electric cell by wires, the current passes through the filament of the incandescent lamp and makes it glow. With an incandescent lamp, it doesn't matter which of its terminals connects to the positive or negative terminal of the cell. The lamp will glow as long as the circuit is complete and current flows through the filament. There is one more fascinating fact. Sometimes an incandescent lamp does not glow even when connected to a cell. We say the lamp has fused, usually due to a broken filament. A broken filament stops the flow of current, preventing the lamp from glowing. Let us now try to make an LED glow. Activity 3.7. Let us experiment. Point number 1. Take 2 electric cells, an LED of any color, a cell holder that can fit 2 cells, which is given in figure 3.8a, and 2 lengths of electric wire. Point number 2. Remove about 1 centimeter of the plastic covering from both ends of each wire to expose the metal. Point number 3. Connect the 2 wires to the cell holder as given in figure 3.10a. Page number 31. At the right side of the page, there is figure 3.10 making an LED glow, which includes 4 figures. Figure A, where a blank cell holder is provided. Figure B, which has 2 cells inserted in the cell holder. Figure C demonstrates the connection of LED with the battery, where positive and negative terminals of the battery are connected to LED in such a way that the longer wire of LED is connected to the positive terminal of the battery and the shorter wire to the negative terminal of the battery. Figure D demonstrates the interchange of the terminals. Point number 4. Insert 2 cells in the cell holder, taking care that for each cell, its negative terminal is towards the spring side of the holder, which is given in figure 3.10b, and the battery is ready to use. How will you decide which is positive terminal of the battery? The terminal of the holder which is connected to the positive terminal of one cell is positive and the one connected to the negative terminal of the other cell is negative terminal. Point number 5. Now connect the free end of the battery positive terminal wire to the longer wire of the LED and the free end of the second wire to the shorter wire of LED. Figure 3.10c. Does the LED glow? Point number 6. Repeat the above step but interchange the wires connected to the LED. Figure 3.10d. Does the LED glow again? You would have observed that the LED glows in the first case, figure 3.10c, and does not glow in the other, figure 3.10d. It is because the current can pass through the LED in one direction only. The current passes through the LED only when the positive terminal longer wire of the LED is connected to the positive terminal of the battery and negative terminal shorter wire of the LED is connected to the negative terminal of the battery. When current passes through the LED, it glows. Always take care to connect an LED correctly in a circuit to make it glow. At the bottom of the page, Dive Deeper box is provided, which explains how to recognize terminal connections inside a battery holder. This box reads, sometimes you may come across a device in which the cells are placed side by side. Then, how are the terminals of the cells connected? If you carefully observe inside the battery compartment, you will usually observe a thick wire or metal strip connecting the positive terminal of one cell to the negative terminal of the next. To help with proper placement, plus and minus symbols are typically printed inside. In this box, the pictures of 2 sets of batteries are given which are connected correctly. Page number 32, 3.2.6 Electric Switch. A dialog box is provided at the top of the page where a girl is asking how does a switch turn on or off the torchlight. Let us first make a simple switch on our own. A figure is provided 3.11 where a switch is in off position in figure A and in on position in figure B is given. Activity 3.8. Let us construct. Point 1. Collect 2 drawing pins, a safety pin or a paper clip, 2 wires and a small piece of cardboard. Point 2. Insert a drawing pin through the ring of the safety pin and fix it to the cardboard piece, ensuring that the safety pin can rotate freely. In figure 3.11a. Point 3. Fix the second drawing pin to the cardboard piece so the free end of the safety pin can touch it. Figure 3.11b. Point number 4. Connect a wire to each drawing pin. Our switch is ready. Let us now test our switch. Activity 3.9. Let us test. Before doing this activity, let us know about figure 3.12 given in the bottom of the page at the left hand side. Figure 3.12, an electrical circuit with a switch in A. Off position, B. On position. You can find a circuit which includes cell, a lamp and a switch. Now coming to the test. Point 1. Connect the electric cell, lamp and switch as given in figure 3.8a. Does the lamp glow? Point number 2. Rotate the free end of the safety pin till it touches the other drawing pin as given in figure 3.8b. Does the lamp glow now? When the safety pin touches both drawing pins, it closes the gap and completes the path and allows the current to flow. We call this the on position. Figure 3.8b. Where the circuit is closed and current flows from the cell's positive to negative terminal, making the lamp glow. When the safety pin does not touch the second drawing pin, the gap in the circuit prevents current flow and the lamp does not glow. In this off position, in figure 3.8a, we say that the circuit is open. Note that a switch can be placed anywhere in a circuit. A switch is a simple device that either completes or breaks a circuit. The switches used for lights and other devices at home work the same way, though they are designed differently. Page number 33. At the top of the page, a dialog box is given where a boy is asking, can we represent the circuits in a simpler manner? 3.3 Circuit Diagrams. The various components of an electric circuit can be represented by symbols, which are given in Table 3.2. Table 3.2. Electrical components and their symbols. Let's go through the table provided, having 3 columns and 7 rows, including the electric component and their symbols. The first row has the electrical component of electric cell and its symbol is also provided. Row 2 includes electrical component for battery and its symbol is also provided. Row 3 has electric lamp and its symbol. Row 4 includes light emitting diode LED and its symbol. Row 5 demonstrates switch in on position and the symbol used for it in a circuit diagram. Row 6 has switch in off position and its symbol. Row 7 includes a wire and its symbol. In the symbol for an electric cell, the long line represents the positive terminal while the short line represents the negative terminal, which is given in figure 3.13a. Page number 34. At the top of the page in the left side, figure 3.13 is provided. Positive and negative terminals in the symbols of A cell, B an LED. In the symbol for an LED, the triangle points the direction in which the current can flow. The 2 arrows indicate that light is emitting by an LED, which is given in figure 3.13b. By using symbols to represent electrical components, it is easier to draw and understand electrical circuits. A representation of an electrical circuit using symbols is called its circuit diagram. Activity 3.10, let us draw. Using symbols given in table 3.2, draw the circuit diagram of an electrical circuit given in figure 3.12a and figure 3.10c. Are your circuit diagrams similar to figure 3.14a and figure 3.14b respectively? Two figures are provided in the middle of the page. Figure 3.14, a circuit diagram. A with an incandescent lamp, B with an LED lamp. At the middle of the page, there is another box, dive deeper. This box reads international organizations such as the International Electrotechnical Commission IEC, American National Standards Institute ANSI, and the Institute of Electrical and Electronics Engineers IEEE create standard symbols for electrical and electronic parts. Using the same symbols across the world helps people from different countries and industries understand each other easily. 3.4 Electrical conductors and insulators. At the bottom of the page, there is a girl and a boy who are discussing and asking, why did we use metal wires for making electric circuits? Can we not use some other materials for wires? The boy asks, also, why are electric wires covered with plastic or rubber? Page number 35. Suppose we make wires of materials other than metal and use them for making the electrical circuit. Do you think the electric current will pass through those materials in such a circuit? At the right side of the page, there are two figures which are given. Figure 3.15a, conduction tester. Here you can find a circuit made up of a cell and an incandescent lamp is also attached, and you can find free wires at both the ends. B. Using the conduction tester for testing a material. In this figure, you can find a spoon which is used for testing. Activity 3.11. Let us identify. Point number 1. Connect an electric cell and a lamp while leaving the two ends of wires free as given in figure 3.15a. Point number 2. Touch the two free ends of the wires momentarily. Does the lamp glow? If yes, our tester is ready. We can use this tester to identify the materials through which electric current passes. Point number 3. Collect objects of different materials such as metal spoons, coins, cork, rubber, glass, keys, pins, plastic scale, wooden block, aluminium foil, candle, swing needle, cardboard, paper, and pencil lead. Point number 4. One by one, touch the free ends of the tester's wires to both ends of each object you have collected. Figure 3.15b. Make sure the wires don't touch each other. Does the lamp glow every time? Point number 5. Record your observations in Table 3.3. Table 3.3, identifying conductors and insulators. This table includes 5 columns and 9 rows, named as serial number, object, material it is made up of, lamp glows yes or no, conclusion, conductor or insulator. Row 1. The object which is given is stick. The material it is made up of is wood. Lamp glows? Yes or no? No. Conclusion: conductor or insulator. Here, a blank space is given to you for your answers. Row 2. The object given is scale. The material it is made up of plastic. Lamp glows. Yes or no? The blank space is given for you to answer. Conclusion: conductor or insulator. Here also you can find a blank space to record your answer. Row number 3. Bangle. The material it is made up of is glass. Here you can find the blank spaces for the column lamp glows, yes or no, and conclusion: conductor or insulator. Row 5. Paper strip is the object which is provided and the material it is made up of is paper. Here also you can find blank spaces to record your answers for column lamp glows, yes or no, or conclusion: conductor or insulator. Row 5. The object candle. Material it is made up of wax. Lamp glows, yes or no, blank space is given. Conclusion: conductor or insulator, blank space is given. Row 6. Key. Object is given. Material it is made up of metal. Lamp glows, yes or no, blank space is given for you. Conclusion: conductor or insulator, blank space is given to record your answer. Row 7. Object eraser. Material it is made up of rubber. Lamp glows, yes or no, blank space is given. Conclusion: conductor or insulator, the blank space is provided here. For rows 8 and 9, you can add some more examples for each column. Page number 36. Analyze your observations. Did the lamp glow for all the materials which we discussed in the previous table? The lamp glows for some materials only. This means that electric current can pass easily through some materials but not through others. The materials through which electric current can flow easily are called good conductors or conductors of electricity. The materials through which current cannot pass through are called insulators or poor conductors of electricity. Based on the observations you have recorded in table 3.3, conclude which materials are conductors of electricity and which are insulators. Note it in table 3.3. From your conclusions in table 3.3, you would have realized that metals are conductors of electricity and thus are used for making wires. Another box for dive deeper. This box reads: silver, copper and gold are the best electrical conductors. However, for making electrical wires, mainly copper is used due to its comparatively lower cost and abundant supply. Different types of electrical wires are used for different uses. From table 3.3, you would have also realized that plastic, rubber and ceramics are electrical insulators. Have you now understood why wires are covered with those materials? Conductors and insulators are both important. Electrical wires, switches, connectors of plugs and sockets are made of conductors. Insulators like rubber, plastics and ceramics are used to cover wires, plug tops and switches to protect people from electric shocks. There is a question message for you. Our body is a conductor of electricity. Electric current passing through our body may cause severe injury or even death. Always handle electrical appliances with care. Never touch switches or plugs with wet hands, or use electrical devices in wet areas, or handle equipment with damaged insulation or broken plugs. Another dive deeper box which reads, have you ever wondered how the electricity from a cell or battery is different from the electricity coming from a wall socket? Electricity from batteries usually powers small devices and is of a type called direct current (DC). In contrast, the electricity from power plants that come to the wall socket is known as alternating current (AC) and can run larger appliances. Page number 37. In a nutshell. Now, let us summarize the chapter in some points. Point number 1. An electric cell is a portable source of electrical energy. Point number 2. An electric cell has two terminals. One is called positive while the other is called negative. In an incandescent electric lamp, there is a thin wire called the filament which gets hot and glows to produce light when electric current passes through it. Point number 4. An LED has two terminals. One is positive attached to a longer wire and other is negative, the shorter wire. Point number 5. Electric current can pass through LED in one direction only. An LED light. Point number 6. An LED lights up only when its positive terminal, longer wire, connects to the positive terminal of the battery and its negative terminal, shorter wire, connects to the negative terminal of the battery. Point number 7. A switch is a simple device that either completes or breaks a circuit. Point number 8. The direction of electric current in a closed electrical circuit is taken to be from the positive to the negative terminal of the electric cell. Point number 9. A representation of an electrical circuit using symbols is called its circuit diagram. Point number 10. Materials through which electric current can flow easily are called good conductors or conductors of electricity. Point number 11. Materials through which current cannot pass through are called insulators or poor conductors of electricity. There is a picture of a boy who is motivating you to answer some of the questions from the chapter. Let us enhance our learning. Coming to the exercise of the chapter. At the bottom of the page, there is a picture of a boy who is motivating you to answer some of the questions from the given chapter. Question number 1. Choose the incorrect statement. First, a switch is the source of electric current in a circuit. Second, a switch helps to complete or break the circuit. Third, a switch helps us to use electricity as per our requirement. Fourth, when the switch is in off position, there is an air gap between its terminals. Question number 2. Observe figure 3.16. With which material connected between the ends A and B, the lamp will not glow. Here, a picture is given. Figure 3.16, which includes a cell connected to incandescent lamp, and there are two free ends of the wires connected to them. Page number 38. Question number 3. In figure 3.17, if the filament of one of the lamps is broken, will the other glow? Justify your answer. In this question, figure 3.17 includes a circuit diagram where a two-cell battery is connected to two bulbs. Question number 4. A student forgot to remove the insulator covering from the connecting wires while making a circuit. If the lamp and the cell are working properly, will the lamp glow? Question number 5. Draw a circuit diagram for a simple torch using symbols for electric components. Question number 6. In figure 3.18, let us know about figure 3.18, which includes a circuit diagram in which a two-cell battery is connected with some of the electrical components. The positive terminal of the battery is connected to switch S1 and then lamp L1, then it is connected to switch S2 and then lamp L2, which is now connected to the negative terminal of the battery. There are 4 points. First, if S2 is in on position, S1 is in off position, which lamp or lamps will glow? Second point, if S2 is in off position, S1 is in on position, which lamp or lamps will glow? Third point, if S1 and S2 both are in on position, which lamp or lamps will glow? Point 4. If both S1 and S2 are in off position, which lamp or lamps will glow? Question number 7. In this question, there is a figure provided as a circuit. This circuit includes a battery of one cell, an incandescent lamp inside the lamp holder, and a switch which is in off position. 3 of these electrical components are connected through wires. Now the question is, Vidyut has made the circuit as given in figure 3.19. Even after closing the circuit, the lamp does not glow. What can be the possible reasons? List as many possible reasons as you can for this faulty operation. What will you do to find out why the lamp did not glow? Page number 39, question number 8. In figure 3.20, in which case or cases the lamp will not glow when the switch is closed? Figure 3.20 includes 4 circuit diagrams. 3.20a. In this circuit diagram, we can find a one-cell battery which is connected to electrical lamp through its negative terminal. Now the electric lamp is connected to a switch. Switch is depicted in off position. Now the switch is connected to positive terminal of the battery. 3.20b. In this circuit diagram, the positive terminal of a one-cell battery is connected to electrical lamp and then a switch. The switch is depicted in off position. The other end of the switch is connected to negative terminal of the battery. Figure 3.20c. In this circuit, a two-cell battery is used. The negative terminal of this battery is connected to a light-emitting diode, LED, which is now connected to a switch. This switch is depicted in off position and now it continues to be connected with the positive terminal of the battery. Figure 3.20d. Here also a two-cell battery is used, but the negative terminal of the battery is connected to the switch and positive terminal of the battery is connected to light emitting diode, LED. Question number 9. Suppose the positive and negative, plus and minus symbols cannot be read on a battery? Suggest a method to identify the two terminals of this battery. Question number 10. You are given 6 cells marked A, B, C, D, E and F. Some of these are working and some are not. Design an activity to identify which of them are working. First point, list the items that you require. Second, write the procedure that you will follow. Third, with the items, carry out the activity to identify the cells that are working. Question number 11. In this question, a figure 3.21 is provided. Let us know about this figure. Here, two cells are connected in this figure. The negative terminals of both the cells are connected with a wire. The positive terminals of both the cells are now connected to the terminals of a LED. Now the question is, an LED requires two cells in series to glow. Tanya made the circuit as given in figure 3.21. Will the lamp glow? If not, draw the wires for correct connections. Now, the chapter includes an interesting section here named as exploratory projects. First, suppose that due to some problem, the power supply is disrupted in your area for 2 days. List out which actions from your daily life you would not be able to do. Page number 40. Second, using a solar panel given in figure 3.22a as a source of electrical energy, make a circuit to run a toy fan given in figure 3.22b as given in figure 3.22c. The figure provided here includes figure 3.22a as a solar panel. Figure 3.22b includes a toy fan and a motor. Figure 3.22c is demonstrating a solar panel powers a toy fan through proper connections. Third is, visit an electrical items shop. With the help of the shopkeeper, identify the various types of cells available. For each cell, also find out which device or devices it is used for. Prepare a report. Fourth, prepare a list of objects in your home under 3 categories. First category is objects which are electrical insulators only. Second, objects which are electrical conductors only. Third, objects which are made of both, whose some parts are insulators and some electrical conductors. Let us explore a box given at the bottom of this page. This box lists uses and types of batteries in our daily life. This box includes some of the pictures of various types of cells or batteries which are provided here. This box named as Science and Society. Electric cells or batteries are compact, portable sources of electrical energy that make the use of some electrical devices more convenient. These cells and batteries come in various shapes and sizes for different purposes, such as cylindrical batteries for torchlights, clocks, remotes, toys, button cells for watches, hearing aids, rechargeable batteries for mobile phones, laptops, and electric vehicles. Chapter 3 ends here.
Curiosity. You were just listening to this audiobook, Textbook of Science for Grade 7. Narration, Harsh Priya. Sound recordist, Virendra Rawat. Production assistant, Chetna Sharma. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.